Yeah, once again, good morning, all. Today's class, in today's class, we'll be dealing with a mini project which includes NumPy, Pandas, and Matplotlib. We have seen all of them separately, right? So what if we combine all of them and make a project? Like how can we combine all of them in real world scenarios? So that's what we'll be seeing in today's class. It will be most interesting because we have seen all of them individually, and integrating all of them can really be helpful when we are working with big projects. Now we'll be seeing a small project. I mean, it's not so small, but it can be really helpful. I'll show it. So I'll share my screen. One second. I'll open my folder. Simply I'll open my Jupyter notebook. Am I sharing my screen? Okay. Jupyter notebook. Sorry, I forgot to give a title. Today's our project is IPL team performance analysis. So we have done it using Matplotlib. Like we have seen all the plots, right? Who like which team has more fan base. So in this project, we'll be including everything. What we'll do, we'll have an Excel sheet which loads IPL team performance, and we'll do that using Pandas, and we'll perform calculations like average runs per match using NumPy, and we'll visualize team performance using Matplotlib. So for that, I'll open a new kernel and close all remain. Okay. I name it as mini project. So it also have a data set, right? I mean, or CSV file. So for that, I'll create a CSV file within this. I'll try. I'll try. Okay, I can't add a CSV file from here. I'll open my VS Code and directly create a CSV file. It will be better. Okay, before that, for who, if you are following, like if you are doing it parallelly, and if you haven't installed NumPy, Pandas, and Matplotlib, you can directly install them. In a single command, you can install them, or you can create a requirement file and then install them. So for them, pip install NumPy, Pandas, Matplotlib. I have already installed all of them, so it won't install it again. Like it won't get installed again. Show requirements already satisfied. Requirements already satisfied. For the people who are new, it might take up to a minute. So if anyone haven't, just go through it until we start the class. Okay, I'll create a data set for that. Okay, I already have this. I'll remove this actually because I'll create IPL.csv again. So for that I'm removing it. IPL dot so I can directly write here instead of opening an Excel. I can directly type over here team spaces matches. Okay. Matches played. Total runs, wins, losses. Okay. What all teams do we have? Any idea? Mumbai Indians. Taking this example as we might be familiar with IPL, right? Some random. Like consider this as a points table. Like, this is a season score. Until then, who haven't yet installed all the libraries can do it. Like, it will take only 2 minutes. Taking some random numbers. Enough. So what if I want to view this? I'll refresh it. If I want to open it in Excel, it will directly get opened as rows and columns. You can see that's the power of CSV. So it's most easier for Python to process CSV. As you can see, it's most easier to process CSV files because comma separated values then can directly be converted into rows and columns. So let's go. Our data set is ready. Now we'll jump back into our Jupyter notebook. Okay. So what's our first command? We need to import everything. What all we have installed, we need to import everything. Import NumPy as NP. Run this. Okay. Import Pandas as PD. Import Matplotlib dot pyplot as PLT. So now let's read our okay. Matplotlib, spelling mistake, sorry. Okay, so we have a data set, right? Now we need to load our data set. For that, we'll create a variable PD. We have pandas, right? To load and deal with the data sets, we'll be using pandas as we have seen in our previous classes. And to load our data set into our code, we'll use read CS. IPL.cs. These are data set, right? Okay, got loaded. I want to see if it is loaded correctly. So for that, I'll just print first 5 rows. df dot. It prints just 5 rows. See, it printed. So it's loaded perfectly. What do I need? So my first thing, what should I do? My first thing, I'll use NumPy. I'll use NumPy. Just I want to show all of these three, like how they worked together. So for that, I'll calculate my average. Like I'll calculate the average of all teams runs per match. Average runs per match equal to np dot. So what should I do if I want average runs per match? Like we know that average means sum of observations by number of observations. For that, total runs by matches played. Simple. So what I want to do is, uh, I don't want any floating point value. So for that, I'll just take a round function. I haven't explained it, but round function makes the last round off, like it removes the last 2 digits and prints the nearest value. Total runs cities. So I'm taking it from the data frame, data set, df of. So what you gave here, if it is capital, you need to give capital only. If it is small, you need to give small only. So for that, I'll just copy paste. So what is this 2 here? I want to round off to 2 decimal points. That's it. Not more, just 2. So let me run this. Why? Okay. I haven't closed this. So I have just calculated. So I'll also calculate my win percentage. I think we can see all changes from here also. Okay. Nothing got changed as we haven't executed anything. Win percentage. So also I'm rounding off to nearest value. So for win percentage, what we should do? Total number of wins by matches played. So that will be a percentage, right? So df of wins, view capital, wins, close it, by df of matches played. So this will calculate our win percentage. So this isn't solely enough. We should multiply this by 100. Comma 2. Okay, let me check if parentheses match correctly. I should choose the winner, right? Best team equal to df dot locate df of whose win percentage is maximum. I should check that. Whose win percentage is maximum, they are the best team. Dot id max. So in NumPy we use this id max. So series object has no attribute id max. So did I forget to show anything? Let me remove this name for now. Okay, just I'll try to visualize everything. Let's do that at the ending. So I'll try to visualize each team performance. plt dot figure fig size. What is the figure size? I'll keep it 10 to 15. It will look good, the dimensions. Okay, close this. 10 to 5. I mean, 10 to 15 will not make it because this is the length and this is the breadth. Length should be big and breadth should be less than that. Okay. First thing, I'll try to plot a bar graph. Bar f of teams. Comma. Between what all do I need? How many teams and total runs I need a bar graph so I can decide the winner. Not winner, but the best performing team. So color, I should choose a color, right? Color, I'll choose sky blue. So if you want to check all the available colors, you can go to the documentation. You'll get a better idea. So I should not press shift enter here because I need to set all my X label, Y label and title. So for that, plt dot X label equal to teams, because on X axis I have my teams, right? plt dot Y label, I'll have total runs. Next plt dot title, what will I have? Total runs by IPL teams in a season. And plt dot xticks rotation equal plt dot show. See, you can see. So why did I take x sticks means previously these used to be like Mumbai Indians, a straight line, right? So if I take all as a straight line, the place won't be sufficient. So for that, I made it a bit slant. So for that, I took rotation as 45 degrees. So x sticks basically means uh, I mean, the names on x-axis should be slightly change their angle. So as you can see, the first team, which is Mumbai Indians, they made runs on an average of like 2,900, I guess. So it came in a decreasing order. If we set our data set based on the runs, like not in an ascending or descending order, like we'll get a better representation, I guess. As I have taken in a descending order, it took me like it gave in a descending order as well. As you can see, the top most run scoring team is Mumbai Indians, and least run scoring team is Delhi Capitals. I think you got a better view of what like what a bar does. So a bar graph represents a bar chart. Sorry, no, to use a bar graph, you need to use this one plt.bar to plot what between which two you need between which two columns you need if you want to plot between teams and total runs or teams and total wins. You can also plot that. Just you need to change here row name and column name for that. So color can be anything. I have chosen a color. You can choose the color which you like. As we have seen, a bar graph, a bar chart is done. Now we'll see how a pie chart does. So for a pie chart, I need plt dot figure fig size. I'll take a pie chart should be big, right? Like it is a circle. I'll take same dimensions plt dot pi. So between what all do I need? I just need between, like I want to show win percentage of each team. Percentage label equal to DFT means it will show a pie chart, right? So for a pie chart for each team it should show a label. So for that I'm taking each team's label. If I don't want each team name, I can also take number of wins, but that won't make sense because we won't understand by seeing by number of wins we can't decide the team, right, without seeing the data set. So for that I'll take team. So basically I've seen this in previous class also. So this just means a bit of spacing between each one. And I'll take colors, different colors. Blue, mm, orange. I'll take it as yellow, red, pink, orange, and let me try dark blue. Not sure like it is valid or not. I'll take sky blue only. Sky blue. So this is what I needed for my pie chart and what all do I need. I need a title. PLT dot title win percentage of IPL team of IPL teams. So plt dot show. I'll run this. Okay, it's wrong. Label. Okay, I'll run this again. It's running. What again? Cell number 15. Okay, line 2. I made a mistake. I think I have made a blunder somewhere. Win percentage. Okay. Okay, this is yellow. Okay, this is good now. Looks good, right? So you can see by seeing the pie chart, like you don't even need to see the data set now. You can just see the pie chart and say this number shows Mumbai Indians has highest win percentage, followed by Chennai, then Royal Challengers Bangalore, and the least one is of Delhi Capitals. So in this way, you can also represent your dataset as a pie chart. So this is a bar chart or bar graph. This is a pie chart. So what all do we have? I mean, I just wanted to show like how can you get your dataset again. I have shown using pandas, and then how can you perform mathematical operations like calculating average, calculating win percentage, and showing the same thing in Matplotlib. You just need not show like yeah, like what all you have in the dataset. You need not show all of them, but beyond the dataset, what all you can do using NumPy. So that's the power of NumPy. Like beyond the dataset, you can also calculate the win percentage, the average, and show the same thing in this thing, in a representation, visualization, visual representation using Matplotlib. So I think this thing is clear. Like I just wanted to show a mini project. If you want another project, I'll show it. Like depending on your interest. Do you want another project or should I continue with other topics? Even like is everything clear or should I take another project? So actually the meeting is not done.
Yes, sir.
Okay, do I need another topic to take or should I take another mini project for even better understanding? Like any response, I can take any action. Please, someone suggest me what to take. Okay, move to next topic. That's fine. So the next topic will be machine learning. Start the introduction once again. Start with machine learning. If you want to check, you have different meanings from each websites. Like this is the overview which is given by Gemini. Okay, is my screen visible? I should check. Yeah. So basically, you'll have an overview right in your mind. Like simple. I mean, you have a basic idea, right? What machine learning is, and everyone has their own definition. So, can anyone just quickly say what machine learning is? Just share your ideas. What is it, and why should we learn it?
So machine learning is basically we are teaching a machine or an algorithm through different ways, and it can be done through regression, classification, and other methods.
That's good, Aman. Exactly. And any more answers? Okay. So, yeah. As Aman said, machine learning has the similar definition. Like, it's the ability of a human brain to mimic, like, it's the ability of a machine to mimic the human brain and all the capabilities. Like, we'll train the machine to perform, think like a human, and take the decisions. So that's a bit more complex topic. I mean, we'll use artificial neural networks for them. For now, basically, machine learning is a field of artificial intelligence that enables computer to learn from data and make predictions or decisions without being explicitly programmed. So there is a definition, like not the standard definition also. I just wanted to show. So previously we had taken the data set, right? We made different functions to make predictions out of it, like to show them, to visualize them. And I didn't yet show how to make the predictions. Like if we integrated machine learning into it, it will make predictions like who will win the IPL trophy next year depending on win percentage of this season. So that's the power of predictions, I mean machine learning. So the same data set also can make predictions. I'll show it when we will be working hands on the project, on the mini project. So for that I should cover all my basics, like I should cover the basics. So why is machine learning important? Previously we it used to take a lot of time to make any decision, right? Whether, even for a simple example, if it is raining, should we play outside or should we go outside? We used to take decisions not based on the exact factors. So to make it more accurate, we used to, like, the scientists created modules, and we started using them. We started using modules like decision tree and those things. We kept all our doubts over there, and we used to get better decisions on which we can take the actions. So it also improves efficiency and accuracy in various fields, like in healthcare, finance, and e-commerce. We use machine learning. uh, for example, you buy a product on Amazon, so you will get a recommendation, right? You can also buy this product. So that is due to machine learning only. Like they have set an algorithm that the people who like this product will also have also chances to like this product, and their success rate is 60% for that, because few people see this, and if that is in a more cheaper rate, they might prefer that. And in shopping websites also, like if they have two products and one product is being sold very frequently and another product is not being sold, so instead of checking everything manually, like which product is linked with which product, they'll just deploy a model. So it checks this is the top sold and this is the least sold, so they'll make an offer, buy this and get this free, such kind of offers. And in healthcare also, based on your previous reports, it generates a new report and says you need to take more precautions based on this. and in finance also, in stock markets also. These days machine learning is being used a lot because to make futuristic predictions, and also people make a lot of predictions in stock market, but most of them don't trust them. So for that they might prefer machine learning models because of their accuracy. So I have told, right, recommendation systems, and also, yeah, fraud detection systems. uh, for suppose the lot of credit card frauds taking place, and they gave all the data to the data set and train the model on that. So if something, for suppose, if a mail doesn't contain a title, so it throws it into a spam folder, even if it is spam or not, or if it also has offers like you won a lottery or you won 1 crore rupees cash. So those all messages it will put in I mean spam folder, because it identifies the frauds, right? And also fake alerts. I mean, if you post fake job alerts, like they'll take the name of TCS and they'll take tcs@gmail.com, but that's not valid because TCS uses its official domain for that. Nextstep.tcs something they'll use. So they make frauds like this. So previously they'll train it based on the legal ones, and if something other than that enters, they'll mark it as spam. And self-driving cars, as you know, they also need to be trained. I mean, in which direction it should go, and what if an other vehicle comes in front of it, uh, what should it observe, everything. So there are types of machine learning, as Aman Khan has mentioned: supervised, unsupervised. We'll discuss it basically. Like the basic two types are supervised and unsupervised, and we'll also have reinforcement learning. So for now I'll discuss supervised learning. So what does a supervised learning mean? The model learns from labeled data. That means data with input output pairs. So for example, predicting house prices based on features like area, location and number of rooms. For example, uh, we'll give everything in a label thing, like I have shown. Just like this, we'll give everything. There is a simple data set, but for supervised also you'll have lot many columns and lot many rows. So it will just label based on the request. I mean, you can find relations, like it predicts the house price depending on these things, like what all have, like which houses have the greatest price, in which areas the price of house is more, and depending on number of rooms, is it like is house price depending on number of rooms, if triple bedroom more price, if double bedroom less price. So all things will have a big data set and will train it for like this, like for this input this will be the output. Like if the input is greater than 3, then the output will be like 60 lakhs. If the input is equal to 2, then the output will be like 45 lakhs, something like that. You will train everything. So if you give another new example, it will directly predict that if your house costs this much or less than that. Like this is an example just to make the things clear. It depends on label dataset. Label dataset means for each input we'll have an output and we'll train it according to it. So this is simple example, but we'll be dealing with more complex in our future classes. And common algorithms used are decision trees, linear regression, support vector machines, and neural networks. Okay, neural networks are also a kind of supervised learning only, not exactly, but a small part it uses from it supervised learning. So what next? We also have unsupervised learning. Unsupervised learning basically means the model learns from data without labels and finds patterns. It doesn't have a label. Like Mumbai Indians means 5 wins, Chennai Super Kings 6 wins. It doesn't have any labels like this. Like I just don't want to confuse. I want to differentiate from supervised learning. what it is supervised learning, it has a lot of categories of one type. So depending on that frequency it predicts, right? But in unsupervised learning it doesn't have that approach, but instead what all have a greater value it will make a cluster, it will make a circle, and what all have lesser value it will make another circle. I mean, it will take a common point, and what all falls under this category it will make a cluster of it. What all falls other than this it will take another cluster. If I just want to show, so if if I mark few points, like I have a point here, I have a point here, I have a point here, I have a point here. This is a basic example, and this is my main point, and this is my range. So what all the points lies over this line? So what all the points lies over this circle? So those will be clustered into one. I mean, not this. So this is a cluster, and what all the points lies outside, that's not another cluster, but that is not an interesting thing. So what all falls under this category, they will be a cluster and commonly liked elements. So depending on this it can make predictions. Example, customer segmentation in marketing. uh, for example, if a customer like in a month, if a customer visits more than 15 times to a mall, then this will cluster all those customers, all it will cluster all those customers and make them a group. It will send regular notifications to all of them. Oh, we are missing you, customer, you have been our best friend since you were the regular visitor. We have this kind of offer for you. So these are the least interesting, right? They'll be grouped into another based on their interest, and for them they'll have some other kinds of offer. Like this will be a customer loyalty program. You can see in Zomato, like who are ordering regularly they'll get some discounts, right? So this is also that kind of thing. They'll group the customers of like bigger interests, and this will be discarded or they'll be again grouped based on their interest. So in this way I just wanted to show how clustering works. So for that the common algorithms used are k-means clustering, principal component analysis, and db scan. And next we'll have reinforcement learning, which means the model learns through trial and error by interacting with an environment. So for that we have a best example. If you have ever played online chess, you'll just know, if you make a move it will make a better move depending on the difficulty level you select. If you select easy it will have another move, if you select difficult it will have another move and challenges your brain. So how is that made? It's made using reinforcement learning, because it is also just like a human being before, like it didn't know what to do, what is the next step. But what they have done is, what the scientists have done is, they made a model such that this should be the better step after this. They considered all the maximum possibilities of for example, if in a rook, if a rook moves straight, or if a rook moves straight or left or right, it can move only straight directions, right? It can't move diagonal, it can't move in another direction. It can't move direction in diagonal directions. Other than that it can move in any direction, like it can't also move in L direction, it can just move in straight direction. It will train all of them. This all will be trained, and they'll also train the best possible. If a bishop is in this way, then how can rook affect that, or how can it kill that? These all things they'll train. So when we are playing it uses that data. Before training, like while training also it makes many mistakes, just like us. While coding we will make many mistakes, right? After the mistakes we'll rectify, and for the next time when we are trying to make that mistake we'll recollect, oh, we have made this mistake previously, and we'll not make the mistake again. We'll have the solution. We made the mistake previously and we have the solution, so we won't make it. We'll try to be more efficient. So this is how it learns. The model learns through trial and error by reacting with an environment. So it reacts with will react with changes, right? All the changes will record in our mind, and if the again that incident comes, the next time we'll be alert and we won't do that again. So this is how uh, reinforcement learning works. So the basic examples is AI playing chess, self-driving cars. Self-driving cars also uh, like previously don't have much exposure to the environment. So for that they'll take it outside and they'll just show like it will observe the driver, like what the driver is doing when it is a crucial time, when he will apply the brake or when he will change the gears, so how he rotates the steering, everything he will observe, and also the outside things. If a car is nearby, or the density of front car bumper and like back car and front car, what's the distance and what is the light, everything it will calculate. In night time how should I ride, everything. So it will learn based on this so at first it might make mistakes like crashing into something or just over speeding. It can make few mistakes, but after taking suggestions from the learner, it will automatically try to correct itself. So it takes it a lot of time to learn, but after learning it will be unstoppable, just like Tesla cars. You can see they're self-driving cars, few of them. So common algorithms used in reinforcement learning are q learning and deep q learnings, dqn, we call it dqn. So for machine learning also we use NumPy. NumPy is used for data science as well as machine learning also. So it is the most common thing, yet most powerful, because we use it everywhere we go. So why do we use NumPy in machine learning? In machine learning also we'll have numerical operations, right? In machine learning also we'll have arrays, right? Arrays and matrices. As NumPy is more efficient with arrays and matrices, it will be more powerful over there, because if you want to initialize everything with zeros, you can take zeros function of any size and then you'll keep on changing the values, right? So for that, and we'll also use pandas. Pandas is used for data manipulation, as you know. We'll be using with large data sets. So to take that data set, to load the dataset into our code, we'll definitely use pandas for that, and data frames. And also we'll use Matplotlib and Seaborn. So what all we have covered previously, NumPy, Pandas and Matplotlib, not only they'll be used in data science or data engineering, they'll also be used in machine learning as well. Machine learning has additions from this. So Matplotlib and Seaborn are used for data visualization. It shows the plots like what have more interestingness kind of thing. And the most used one is scikit-learn. Scikit-learn, it is the most famous Python library, I should say, because it provides built-in ML models for classification, regression, clustering. Example, for example, I'll give linear regression. Linear regression uh, comes under scikit-learn. Like we'll use like from sklearn, linear model, import linear regression. We'll do these things. Like tomorrow's our agenda is to learn scikit-learn, and then we'll have TensorFlow and PyTorch. TensorFlow and PyTorch deals with deep learning and neural networks. TensorFlow is developed by Google basically, while PyTorch is developed by Facebook. We'll learn any one of them. So basically, to get started with machine learning, we need to have a basic strong in NumPy, Pandas and Matplotlib, as you are strong, as you have attended all the classes, so that can do good, because you'll have a bit more experience, right? And understanding ML concepts, supervised versus unsupervised. We should work with real world data sets. And we should also practice scikit-learn and PyTorch for advanced projects. I'll teach from basics, like I'll teach what all functions we use and why should we use them. Also taking examples, I'll try to explain them more clearly so that you can use them in your college projects also. So that's the overview which I wanted to give. So learning can take time, but after learning, you should also try to implement it so that you'll get more hands-on experience. So we'll look all of them in our upcoming classes. So that's for now, and thank you so much for attending. So bye all. Have a great day.
Thank you, sir.
Thank you. Thank you all.